everyone, welcome back. Lesson 4, here we go. This is probably one of the most important lessons in the whole entire Trig unit, so pay attention, come to my office hours for questions, okay? You will use what we call the unit circle all the time, okay? In the future. So, the unit circle. What is the unit circle? The unit circle is literally just a circle with a radius that has 1 unit. So far what we've done is the radius could be anything. It could be 5, it could be 2, it could be 100, we don't know, okay? But now the radius is always going to be 1. And that changes things a little bit, okay? Actually, let me kind of go over here to the side. You don't have to write this right now. A couple sections ago, or last section, I don't remember when it was, they might have given you a point. Like they said, oh, here's point 34, let's say. This is the point 34. And then what are the trig functions for it? And you were taught to find the trig functions by saying, okay, I went out 3, I went up 4, and so then you would find the radius by doing Pythagorean theorem. The radius would be 5, and then you could have the opposite and the hypotenuse, 4/5 for the sine, or adjacent hypotenuse 3/5 for the cosine, and then opposite over adjacent tan 4/3, etc. So you would do that, okay? But now the radius is 1, okay? And so you're going to go out on the x and up on the y for this point, xy, but the radius will always be 1 here, okay? And that makes it a unit circle. So when I look for the sine, before we said, oh, okay, opposite over hypotenuse, the opposite was y, and then the hypotenuse was r. But now that the radius is 1, because we are in the unit circle, that would be y over 1, which is just y. So the sine of the angle when you're in the unit circle is just the value of y, okay? Likewise, if you look at cosine, cosine is going to be adjacent over hypotenuse, which we said before was x over r. Oops. Okay, x over r. Well, now the radius is 1, so that's x over 1, and so your cosine is just x. Okay? And then we had said tangent was the opposite over the adjacent, and so in this case, I did it again, here we go. In this case, that's going to be y over x, okay? Still y over x, whatever the y is, whatever the x value is, that's going to be your tangent of theta, okay? Now, please keep in mind that we do have our reciprocal functions. So for sine, we have the cosecant, okay? Cosecant of theta. If sine is just y, the cosine is going to be 1 over y. It's the reciprocal, okay? For cosine, the reciprocal is going to be secant. So the secant of theta is going to be 1 over x. So cosine is just x. The secant is going to be 1 over x. And then the cotangent of theta, if tangent is y over x, cotangent is going to be whatever the x value is over y. Okay, and so we are going to use the fact that the sine is equal to y, the cosine is equal to x, and the tangent equal to y over x to create our unit circle. Okay, and because sine is y and cosine of x, the coordinates of any point on a unit circle can be written as cosine theta, sine theta. Okay. This one is our x, this one is our y. So that point, whatever the x is, that's your cosine. Whatever the y is, that's your sine, okay? And then you have to do a little math to find the tangent because it's y divided by x, all right? And so that's because it's in a unit circle with the radius is 1. Okay, now we are going to create our unit circle. The unit circle basically goes through these very common degrees, 30 degrees, 60 degrees, 90 degrees. We're actually going to go through all of them, okay? It goes through all these common angles that you see a lot of, and we're going to recreate this entire unit circle so that way you have it, and then you can use it to answer any question, okay? So these are our special angles, 30, 45, 60, etc., and they come from our special triangles. So really quick, if we had our 30, 60, 90, okay, let me erase that. Okay, if we had our 30, 60, 90, remember we said here's, let's say, a 30-degree angle, this one up here is 60 degrees, and then this is 90. But remember, we're in the unit circle, so the radius is 1. The hypotenuse is 1. Okay? In a 30, 60, 90, the hypotenuse was equal to 2 times the short leg. So then the short leg is going to be half of the hypotenuse, which is 1/2. Okay? And then the long leg was the short leg times the square root of 3. So I take 1/2 and I multiply it by square root of 3, and we get root 3 over 2. Okay? So in a 30, 60, 90, when the radius or the hypotenuse is 1, these are the values of the other two sides, always. Okay? So for 30 degrees and 60 degrees, we have these angle measures. Okay? Now, for a 45, 45, 90, because we've already, we've looked at that too, and that's our other special triangle. Okay? So 45 and 45 here. All right, now if, again, our hypotenuse is 1, in a 45, 45, 90, the hypotenuse is equal to the side times the square root of 2. So to find the length of the side, we can divide 1 by root 2. 1 over root 2, if I rationalize, is the same thing as root 2 over 2. Root 2 over 2. Remember, the sides are equal because it's an isosceles triangle. So when I talk about these numbers, they come from the 30, 60, 90 special right triangles, and they come from the 45, 45, 90 special right triangles, okay? So they're not just numbers I'm making up. Okay, let's skip over this chart. I'll come back to this in just a moment and go back down to page 3. 1, 2, and 3. Here we're going to create our unit circle, okay? In a unit circle, you have all the information for the special angles, plus what we call the quadrantal angles. I'll talk about those in just a second. And we have the points for either of them, and it's the degrees and the radians. So I'm going to start in this first quadrant over here. I'll do 0, 360 degrees at the very end, okay? But in this first quadrant, notice we have the 30 degrees, 45, and 60 degrees. Those are going to be the special angles we talk about all the time, okay? Now, with a 30-degree angle, first of all, okay, our radian measure is pi over 6. If I were to change 30 degrees to radians by multiplying by pi over 180, it would reduce to pi over 6. So you're going to get questions that have pi over 6 in them, or you're going to get questions that have 30 degrees. You need to know that they're both the same angle, okay? Now, for your 30-degree angle, so here's my 30-degree angle, okay? I'm going to create a triangle. And we said our radius is 1, okay? And just a moment ago, I said, okay, if the radius is 1 or the hypotenuse is 1, then the short leg is going to be 1/2 because the hypotenuse is 2 times that short leg. 2 times 1/2 is 1. And then the long leg, remember, so the angle 60 degrees is going to be up here. The long leg will be the square root of 3 over 2 because it's 1/2 times the square root of 3, or the short leg times the square root of 3. So based on this 30, 60, 90 triangle, what I have is that x is equal to root 3 over 2 and y is equal to 1/2. So that is the point. X is root 3 over 2 and y is 1/2. Now remember, we just discussed that the x is the cosine of theta and the y is the sine of theta. So based on this unit circle right here, if I asked you what the sine of 30 degrees is, you could quickly look at, oh, okay, my y value for 30 degrees is 1/2, so the sine of 30 degrees is 1/2. Or if I said cosine of 30, you could say, oh, it's root 3 over 2. Okay? And so that's how it works. It's based on this triangle, and we get this point, and we said because the radius is 1, the cosine is x, and the sine is y. Now notice it doesn't have the tangent. You have to figure that out, because 1/2 divided by root 3 over 2, etc., you'll find the tangent, y divided by x. I'll look at that in just a moment, okay? All right. Now on to 45 degrees. I'm going to erase this triangle or else it's going to get too messy. You can keep it if you would like. Okay. Now I'm going to look at 45 degrees. Okay, to start, 45 degrees is going to be pi over 4 in radians. So if I were changing 45 degrees to radians, multiply by pi over 180, I get pi over 4. Okay? All right. Now let's look at this triangle, 45, 45, 90. Okay? So if this angle is 45 degrees, this angle also has to be 45 degrees. Now we said the hypotenuse is 1 because we are in the unit circle. Okay? And then what I just discussed was this. In a 45, 45, 90, the side length is, or excuse me, the hypotenuse is the side times the square root of 2. So if I'm looking for the side, I take 1 divided by root 2 and then rationalize. I get square root of 2 over 2, square root of 2 over 2. Okay? So again, this is all coming from the 45, 45, 90 degree triangle with a hypotenuse or radius of 1. And so we can see here again, x is equal to root 2 over 2, y is equal to root 2 over 2. So my point is root 2 over 2, root 2 over 2. Okay? And that's for 45 degrees. And like we said, okay, x is the cosine, so the cosine of 45 degrees is going to be root 2 over 2. The sine of 45 degrees will be root 2 over 2. Okay? So again, it's just an easy way for you to look at a unit circle and say, oh, okay, I don't need to figure out what the sine of 45 degrees is because I can just look at the y value and say sine of 45 is root 2 over 2. Okay? Now on to the 60 degrees. I'm going to erase this again because it'll get too messy if I don't. All right, sine of 60 degrees. Okay? First, the radian measure is going to be pi over 3. Okay, so notice pi over 3 is 60 degrees, but pi over 6 is 30 degrees, so that it's kind of like the 6 and the 3 interchange. I don't know, there's things I notice, weird things that I notice, okay? So 60 degrees is pi over 3, 30 degrees is pi over 6. But let's look at the 60 degree triangle, okay? So here's my right angle. Now my angle is 60 degrees. That leaves up here 30 degrees, okay? The radius or hypotenuse is 1 because we are in the unit circle, and it's the same exact triangle. It's just flipped over as the 30 degree, okay? So the hypotenuse is 2 times the short leg, so the short leg again is going to be 1/2, okay? Because 1/2 times 2 is going to be 1 for the hypotenuse. And then the long leg is the short leg times the square root of 3. 1/2 times root 3 is just going to be root 3 over 2. It's the same numbers, they're just flipped over because the 30 and the 60 flipped over. And so now your x is 1/2, your y is root 3 over 2. That becomes our point. X is 1/2, y is root 3 over 2. And again, so if I asked you what the cosine of 60 degrees is, you would tell me 1/2. Or if I asked you the sine, you would say root 3 over 2. And this could be for 60 degrees, or it could be for cosine pi over 3, or sine pi over 3. Okay? You'll notice here, don't draw this, you'll notice here that these are just switched again because the 30 and the 60 degrees in the triangle switched. Okay? All right. I'll do 90 in just a moment, okay? Now, going to this second quadrant, okay? The cool thing is we are just going to repeat what we had in the first quadrant. If you watch this, 120 degrees here has a reference angle. Remember, reference angles are where is the angle it creates with the x-axis. So even though don't draw this, my angle is 120 degrees, the reference angle here is going to be 60 degrees. Okay? Because from 120 to 180, that's another 60 degrees. So it has a 60 degree reference angle. Because it has a 60 degree reference angle, the point is exactly the same. The point is also going to be 1/2 root 3 over 2. Okay? So, cosine of 60 degrees, sine of 60 degrees, I'm going to fix this in just a moment, is almost the same as your 120 degrees. Again, because that reference angle here is also 60 degrees. Okay? Now, I say almost because if I look at this graph, my x's on the quadrant 2 here are negative. Okay? Right? On this side, we have positive x's. We have positive x's. On this side, we have negative x's, right? Just our normal graphing. And so what happens, I said it was almost the same because your x is actually, negative. This is a negative 1/2 root 3 over 2. And that's because x on the quadrant 2 is negative, okay? So if I ask you what cosine of 120 degrees is, you could tell me it's negative 1/2. Or sine of 120 degrees is positive root 3 over 2. So sine of 120 and sine of 60 are actually the same exact answer. I'm going to talk a little bit more about that in later on as well. Okay? Oh, we forgot to do the radians. The radians of 120 degrees, 2 pi over 3. Notice the radians over here is pi over 3. And then for 120, it's 2 pi over 3. You'll start seeing the patterns with the radians as well. Okay? All right, keep going. 135 degrees now. This radian measure is 3 pi over 4. Notice the pi over 4 was for 45 degrees. 135 is 3 pi over 4. Okay? And that's because for this angle here, okay, for this angle of 135 degrees, this reference angle is 45 degrees. 180 minus 135 is 45, okay? So just like the 60-degree angle, one more, okay? Just like the 60-degree angle, the 45 or the 135 are the same exact point as well, except your x is negative. So, let's see, root 2 over 2, root 2 over 2. Oops, my x is negative. I'm trying to erase that. Okay, so it's also root 2 over 2, root 2 over 2 because it's a 45-degree reference angle, but x is negative. Okay, so the cosine is negative, the sine is positive. Okay, moving on, 150 degrees. Okay, 150 degrees, the reference angle is the radian is 5 pi over 6. Notice for 30 degrees, it's also pi over 6. So it went pi over 6 and then 5 pi over 6. So all the 30-degree reference angles are going to be over 6. Pi over 6, 5 pi over 6. You'll see the next one is 7 pi over 6. Okay, and so again, this is a 30-degree reference angle. I went 150 degrees, and then to get to 180 here, I have to go 30 degrees. So the reference angle is 30 degrees. That tells me that my point is going to be the same as my 30-degree angle. Oops. My 30-degree angle here is root 3 over 2 1/2. So for 150 degrees, it's also going to be root 3 over 2 1/2. But the x is negative, okay? So the numbers aren't changing. It's just where you are on your xy coordinate system. Is x positive? Is x negative? Is y positive? Is y negative? All those numbers are the same because it's 30 degrees, 45 degrees, or 60 degrees, okay? I'm going to keep going. I'll do the 180 in just a moment. 210 degrees here. Okay, the radians measures is 7 pi over 6. So all your over 6's have a 30-degree reference angle. 180 to 210 here is 30 degrees. Okay, so 30-degree reference angle. The 30-degree angle had the point, as we just mentioned, root 3 over 2, 1/2. Just like in the one above it, except now in this, I put it in the wrong space, my bad, hold on. We're doing it for the 210. Erase that. For the 210 degrees, root 3 over 2, 1/2. There we go. Okay, but now we're in the third quadrant, in the third quadrant, your x's are negative, your y's are negative, okay? And so for this point, although the numbers are the same, it is negative root 3 over 2, negative 1/2. So for all of these points, they're going to be the same numbers, but x and y will be negative. So if I ask you what the cosine of 210 degrees is, you will say negative root 3 over 2. Or if I say the sine of 7 pi over 6, you will say negative 1/2, because x is cosine, y is sine. Okay? And we keep going. 225 degrees, the radian is 5 pi over 4, okay? Notice from 180 to 225, that's a 45-degree reference angle. So this has the same numbers as the 45-degree angle in the first quadrant. Root 2 over 2, root 2 over 2. But as we just said, x is negative and y is negative in the third quadrant. Okay? And then 240 degrees, the radian is 4 pi over 3. And then this is a 60-degree reference angle. 180 to 240 is 60 degrees. Okay, so 60 degrees, we're going to use the 60-degree point. And that 60-degree point we said was 1/2 root 3 over 2. But they're both negative because you're in the third quadrant. Okay. And then the fourth quadrant. Again, all the same numbers. But now in the fourth quadrant, your x is positive and your y is negative. So when we rewrite our points for 30, 60, and 30, 45, and 60-degree angles, okay, the x will be positive and the y will be negative now. Okay. All right. So 300 degrees is in radians 5 pi over 3. Remember I told you the over 3's have the 60-degree reference angle, okay? You'll see if you look at this whole thing, 60 degrees is pi over 3, 120 is 2 pi over 3, 240 is 4 pi over 3, and now 300, this also 60-degree reference angle, okay? Because 300 to 360, okay, is 60 degrees, also is 5 pi over 3, okay? Remember, reference angles always come from the x-axis, so we're on closest to that 360. 360 minus 300 is 60 degrees. So, our 60-degree reference angle, the value of the point is 1/2 root 3 over 2, but in the fourth quadrant, x is positive, y is negative. Okay. Next one, 315 degrees in radians is 7 pi over 4. All of the pi over 4's, 7 pi over 4, 5 pi over 4, 3 pi over 4, okay? These are all 45-degree reference angles. 315 to 360 degrees is 45 degrees, and so our 45-degree point from quadrant 1 is root 2 over 2, root 2 over 2, but we are in quadrant 4 now, so the y is negative. Okay? And then the last angle is going to be 330 degrees. This has 11 pi over 6 as a radian measure. I'm going to rewrite it. Okay? All of the over 6's, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6, these all have a 30-degree reference angle. Okay? Your 30-degree angle had a point of, root 3 over 2, 1/2. Okay? But in the fourth quadrant, the y is negative. Okay? So, you've basically filled out 30, 45, and 60-degree angles for every single quadrant. Okay? They are all the same numbers because the reference angles are all the same, except some are positive and some are negative depending on what quadrant you're in. Okay? And based on this, you can find the sine of 300 degrees, or the cosine of 315, or the tangent of 5 pi over 6, because you can do tangent as y over x's. Okay? All right, we just have to fill in the quadrantal angles, okay? These are the ones that are at 0, 90, 180, and 270, okay? So our last part here, let's use blue. All right, 0 degrees, first of all, is 0 radians. 360 degrees is 2 pi radians. This is the same exact angle, okay? 0 degrees and 360 degrees are the same exact angle. All right, now, because we are in a unit circle, this radius here is a radius of 1. So this point right here becomes the point x is 1, y is 0. Okay? And so, again, it's not an angle per se, okay? It just lands on the axis, so we call it a quadrantal angle, okay? And it's because the radius is 1, the unit circle radius is 1, and so it goes all the way out to 1 where the y is 0, okay? I'm going to erase that blue. There we go. All right, going up to the 90 degrees, okay? 90 degrees has a radian measure of pi over 2. And then this point, if you look at right here to this point, radius is 1, okay? Since the radius is 1, you're going up to 1 on the y. The x is 0, okay? And so if you tried to find your cosine and your sine, the cosine of 90 degrees is 0. And the sine of 90 degrees is 1. So it works the same way, it just happens to have a special number to it. Okay? So then 180 degrees, the x we go out to, oops, I want to do it in blue. The x we go out to -1, the y is 0, that's the point there. And 180 degrees is equivalent to pi radians. And then 270 degrees is equivalent to 3 pi over 2. Okay? And this point down here, the x is 0, and then the y is -1. Okay? And what you've just done is created your unit circle. Okay? Based on this, you can answer many, many questions that are going to come up to you. Okay? So I'm going to go up, and I want you to look at this table here. It's already filled in. You can pause it and fill it in and then come back and I'll explain it to you, okay? So pause and fill it in. Okay, so let me explain this table to you. This table is your first quadrant, okay? Let's look at this row right here. The angle is 30 degrees. The radian measures is pi over 6, okay? The sine, which we said was equal to y, was 1/2. The cosine is equal to x, which is √3 over 2. Then the tangent. Tangent is not on your unit circle. You have to find that value. You find that value for tangent by doing y divided by x, okay? So y divided by x is going to be 1/2. Oops, I'm going to make it a little bit smaller. 1/2 divided by √3 over 2. It's the sine over the cosine, y divided by x. And if you do the math on this, okay, I'll show you in just a moment how you can do that. You get √3 over 3. So you can find the tangent using the sine and cosine from the point √3 over 2, 1/2, which is on your unit circle, okay? These are all the tangent values for 30, 45, 60, 90, 180, 270, and 0. Okay, we did the y divided by x. All of your answers for sine, cosine, and tangent, these will always be your answers, but sometimes they will be negative or positive depending on which quadrant you're in. Okay, so if you have that, honestly, I usually have people memorize all this. I have my students memorize the unit circle, and so that way it just comes so fast to you, and you don't have to keep looking at papers to do it, okay? And the more you memorize, the easier it'll be for the future. So, if I were to come down here, we're going to skip down here to sine of 150 degrees now, okay? Well, you can look at your unit circle. If I look at my unit circle, 150 degrees right here. Sine is my y value, so the sine of 150 degrees is just going to be 1/2. Notice I didn't do any work. I don't need to. Okay? This is it. This is all I need to do. Okay? Sometimes you will have to do work, like the tangent of 300 degrees. Tangent is y divided by x. So when I go to 300 degrees on my unit circle, okay, coming down here, I see my y is negative root 3 over 2, my x is 1/2. So I'm going to do negative root 3 over 2 divided by 1/2. Let's do the work on that. Oops, where am I? Here I am. So, negative root 3 over 2 divided by 1/2. How do you divide fractions? You multiply by the reciprocal. So I'm going to take this, I'm going to multiply by the reciprocal here. These are your complex fractions that we learned last chapter. So negative root 3 over 2 times 2 over 1. I flip the 1/2 over. And you can reduce. The 2's cancel, and I'm left with a negative root 3. Okay? You'll notice 300 degrees, okay, answer is root 3. That's because it has a 60-degree reference angle. See where this tan of 60 degrees is root 3? It's the same answer. The only reason we have a negative value here is because it happened to be in the 4th quadrant, which changes our x and y's to positive and negative, etc. Okay? And so that's why your numbers are always going to be the same. These values will always be the same. Sometimes they're positive, sometimes they're negative. Okay? And you'll start getting all the patterns and you'll start remembering all of these values. Okay? All right, cosine of 225 degrees. Look at my unit circle. 225 degrees. Here I am. Cosine is x, so it's negative root 2 over 2. And that's the answer I put down. Oops. So, answer, negative root 2 over 2. That's it. You don't have to do anything for that one. It's just the x value on 225. All right. Cotangent of 315 degrees. Okay. Let me come over here really quick. On the previous page, we said the sine of theta was y, the cosine of theta was x, and the tangent of theta is y divided by x, which we've used all of those, okay? But remember, the reciprocals are going to be 1 divided by y. You have to do work for cosecant. For secant, it's 1 divided by x. You'll do the work on that. And for cotangent, it's going to be, instead of y divided by x, it's going to be x divided by y. So, oops. So when I go to cotangent of 315 degrees, you could do it a couple ways. If you're familiar with your tangent values, you could just take the reciprocal there, or you can actually do the x over y. You'll start, again, like I said, you'll start seeing the patterns. So I'm going to go to 315 degrees. I'm going to look at my x and my y. So 315 degrees, I see it's root 2 over 2, negative root 2 over 2, and so those are the values. Root 2 over 2 divided by negative root 2 over 2. When you multiply, when you divide, you multiply by the reciprocal, so root 2 over 2 times negative 2 over root 2. So I flipped the bottom one, multiplying by the reciprocal. Okay, the 2's go away, the root 2's go away, root 2 over root 2 is just 1, and I'm just left with this negative here, and so my answer is a negative 1. When you cancel everything, it's just negative 1. Okay. If you tried to find the tangent of 315 degrees, you can do that, and then take the reciprocal, and then you would have your cotangent. So there are a couple ways you can do it. Tangent of 240 degrees. Just for time's sake here, I'm just going to go through it. Remember, tangent is y divided by x. So if I look at my 240 degrees, my y is negative root 3 over 2. My x is a negative 1/2. And so now I'll divide these values by multiplying by the reciprocal. Negative root 3 over 2 times negative 2 over 1. These two negatives make a positive. The 2 divided by 2 is 1, and I'm just left with a positive root 3 over 1, which is just root 3. Again, notice it's the same answer as tangent of 300 degrees, or similar answer, because they are both 60-degree reference angles. The only difference is it was a different quadrant, which makes x's positive or negative depending on where you are. Okay? Secant. So secant is the reciprocal of cosine, and the reciprocal of cosine is just going to be 1 over x. So if you look at the cosine of 300 degrees, okay, you'll see that the cosine is going to be 1/2 for 300 degrees. And so you take 1 divided by 1/2, or you can just take the reciprocal of 1/2. And the reciprocal of 1/2 is 2. So it's 1 times 2 over 1, because when we divide two fractions, we multiply by the reciprocal, and we just get 2. Okay? So you can look at it that way. You can also say, okay, cosine of 300 degrees is equal to 1/2. Take the reciprocal of this, and you get 2 also. Okay? So you can look at it either way. 11 pi over 6. Cosine 11 pi over 6. So you got to look. You say, okay, 11 pi over 6, I see at the 330 degrees, okay? My cosine is equal to my x value. So this is 330 degrees. You can look at it that way, okay? And the x value there is going to be root 3 over 2. And we're done. We don't have to do anything. Cosecant 7 pi over 4. 7 pi over 4 is 315 degrees. Okay? So, you can do this again a couple of different ways. All right? Oops. Cosecant is going to be 1 divided by y. If I look at my y value for 7 pi over 4, I see that it's a negative root 2 over 2. Oops. So I have 1 over negative root 2 over 2. And what do we do when we divide fractions? We multiply by the reciprocal. So it's 1 times negative 2 over root 2. And you get negative 2 over root 2. We like to rationalize. I would accept negative 2 over root 2. But if I rationalize this, okay, taking negative 2 over root 2, you can multiply by square root of 2 over square root of 2. I'm running out of room here. Let me move it. Okay. That's going to be negative 2 root 2 over 2. And then my final answer, I'm going to cross those negative 2 over 2 out, and I get negative root 2 left over. Okay? So cosecant 7 pi over 4 is going to be a negative root 2. Just like the cosine, the secant one above here, you could do it the other way. You could find the sine of 7 pi over 4, flip it over, and then rationalize it, and you'll get negative root 2 there. Okay. Sine of 4 pi over 3, I go to my 4 pi over 3. It looks like it's going to be in my third quadrant. It's at the 240 degrees, okay? You don't need to write that. I'm just showing you where it is if you're having a hard time, okay? Sine is the y value, and my y value is negative root 3 over 2. Okay. Tangent 3 pi over 4. So I look at 3 pi over 4. I remember that tangent is y divided by x. Tangent 3 pi over 4 is in the second quadrant. My y is root 2 over 2. My x is negative root 2 over 2. And so when I multiply by the reciprocal, root 2 over 2 times negative 2 over root 2. And then I can cross cancel. 2 divided by 2 is 1. Root 2 over 2 is 1. And I have that negative in there, so that's a negative 1. Okay. Notice this is the same answer as cotangent. No, that's not the one I want to do. Oh, I guess cotangent 315 degrees, okay? Because it's a 45-degree reference angle. So tangent of 45, tangent of 135, tangent of 225, tangent of 315 will be 1 or negative 1. It always comes up that way, okay? Last couple here, sine 7 pi over 6, so I go to 7 pi over 6, that's the 210-degree angle, okay? The sine is going to be the y value, and the y value is going to be negative 1/2 there when you look at your unit circle. Okay. And then the last one, secant pi over 2. So pi over 2 is your 90-degree angle, okay? And secant is going to be 1 divided by x because it's the reciprocal of cosine. So on that 90-degree angle there, it's 1 over my x is 0 for 90 degrees, okay? If I look here, here's my 90-degree angle, pi over 2. My x is 0. So I have 1 over 0. Please be aware that this is an undefined answer. Okay? So sometimes you will get undefined. You can get an answer of 0. Why can't I write this? It is possible to get an answer of 0 for some of them, like the cosine of 90 degrees is 0. But the secant of 90 degrees is undefined. So it is possible to get undefined and answers and 0 answers, okay? If you look at the chart above, you'll see that tangent of 90 degrees is undefined, but tangent of 180 degrees is 0. It just depends on where your 0 is. And whenever there's a 0 in the denominator, okay, that is undefined. So just be careful. 0 divided by 1 is equal to 0. 1 divided by 0 is equal to undefined. Okay? Make sure you know the difference between the two. Okay? So that's how you answer your questions for the unit circle. The last thing I'm going to do is go over where is it positive and negative. Okay? Really quick. I'm not going to spend too much time on this. In the first quadrant, your x's are positive, your y's are positive. In your second quadrant, your x's are negative, your y's are positive. In the third quadrant, x is negative, y is negative. And in the fourth quadrant, your x is positive, your y is negative. Oops. Okay? And so what happens is all sine, cosine, tangent, plus the reciprocals are going to be positive here in the first quadrant. In the second quadrant, because sine is your y value, the sine is going to be positive here. And when I say the sine, I also mean cosecant. The reciprocal is going to be positive, okay? In the third quadrant, because they are both negative, the only ones that are going to be positive is tangent will be positive because it's y divided by x and two negatives make a positive. So tangent values will be positive in the third quadrant. And in the fourth quadrant, the cosine, because cosine is the x, the cosine is going to be positive in the fourth quadrant. So if you know all of this, which ones are positive, where, you can kind of just memorize the first quadrant and then go from there, okay? So in quadrant 1, we say they all are positive. In quadrant 2, the sine is positive. In quadrant 3, the tangent is positive. And in quadrant 4, the cosine is positive. And again, cosine goes with secant, tangent goes with cotangent. That's like kind of automatic because they're reciprocals of each other. So cosecant goes here, cotangent here, and secant here. These are where your positive values. So if the sine, let's say we're doing a sine function, okay? Sine will be positive in the first and second quadrant. So if you're doing a sine that's in the third or fourth quadrant, your answer should be negative, okay? There's a little acronym that we say for this. It's A, S, T, C. All students take calculus. Okay, here's your A, S, T, and C. All students take calculus. A for all of them are positive. S for students and sine, the sine is positive. T for tangent and take, the tangent is positive. And then C in calculus for cosine, the cosine is positive. So in those quadrants, only those specific trig functions are positive. Okay? So if I ask question 1 here, if tangent is greater than 0, that means tangent is positive. Okay? Which quadrants could the terminal side of the angle lie? Because tangent is positive, well, it's positive in the first one. All of them are positive in the first. And then the T is the third quadrant. You would just list it as 1 and 3. Okay, that's it. Where is it positive? 2, secant. Secant goes with cosine. okay? And less than 0 means it's negative. So we want to know, where is the cosine negative, okay? Well, if it's positive in the first and fourth quadrant, because all is the first quadrant, cosine is the fourth quadrant. If it's positive in the first and fourth, that means in the second and third, it's going to be negative. All right. Next one, if the sign is positive, which quadrants are we going to be in? So we're in the all students quadrants, because students is sign, okay? So that's 1 and 2. And then the last one, this one's going to be a little bit more complicated. It says, if the cosine is less than 0, that's negative, and the cotangent, that's the same as tangent, is positive. So tangent is positive. We're going to look at which, so it has to satisfy both. Which is it going to be? So if the cosine is negative, okay, we just saw that. That was in 2 and in 3. Those are the quadrant where the cosine is negative, in quadrant 2 and quadrant 3, okay, because it's positive in 1 and 4. And then if the tangent is positive, okay, we said that's in quadrant 1 and quadrant 3. So what we want to know is, where is the cosine negative and where is the tangent positive? Okay, has to satisfy both. Well, you can see here that the overlap is 3. So cosine is negative in 3 and the tangent is positive in 3. So that is where your angle is going to be, quadrant 3. And we are done. Good job. This is honestly such an important section. If you've made it this far, congratulations. And if you write "I love math" at the top of your homework, I will give you 1 point extra credit because you listened to this entire thing. So good job, you guys, okay? I also want to show you guys that I have included an attachment just for the unit circle. So if yours got messy, you could use this one as your unit circle when you're answering questions, okay? But good job. Please come to my office hours with questions. Again, this is a super important section that I wanted to make sure you guys all understand everything. Take care. Have a great day.